Hello and welcome to Software Testing from Scratch, brought to you by Eduonix. My name is Richard Martin and this is Chapter 8, Test-Driven Development. In this chapter we'll be covering what is test-driven development, why should you use test-driven development, some best practices and some myths. So test-driven development is an evolutionary approach to development which combines test-first development, where you write a test before you write just enough production code to fulfill that test, and refactoring as well. So what's the primary goal of it? One view is the goal of test-driven development, or we'll abbreviate it just as TDD, is specification and not validation. In other words, basically, it's one way to think that your requirements or your design before you write your functional code, implying that TDD is both an important agile requirement and an agile design technique as well. Another view is that TDD is a kind of programming technique as well, I suppose. The first step is to quickly add a test, just enough to try and make the code fail. You don't have to know much about the code in the first place, only what test you can run that will pretty much guarantee it will fail. And next, you run your tests, often the complete test suite, although for sake of speed you may decide to only run a subset, a few tests just based around a certain unit of the software that you want to test first, just to ensure that the new test does in fact fail. After that, you can update your functional code to make it pass the new test. Think of it as designing a bit of software whilst you design a test to go with it. It kind of makes your software become testable by design, which is very good. And of course the fourth step is to run your test again. If they fail, you need to update your functional code and retest again. Once the tests pass, the next step after that is to start over again. You may first need to refactor any duplication out of your design as needed, which is turning TFD into TDD. And incidentally, TFD is test first development. So here we can see this life cycle where you write code, you run a test, you refactor, you add a test, you watch the test fail, and then you write code again. So if you go through that step by step, number one, say add a test. In test-driven development, each new feature begins with writing a test. This test must inevitably fail because it's written before the feature has been implemented. If it doesn't fail, then either the proposed new feature already exists or the test is defective. To write the test, the developer must clearly understand the feature's specification and requirements. The developer can accomplish this through use cases and user stories to cover the requirements and exception conditions. And of course, can write the test in whatever testing framework is appropriate to the software environment itself. This could also be a modification of an existing test. This is a differentiating feature of test-driven development versus writing unit tests after the code is written. It makes the developer focus on the requirements before writing the code, which is a subtle and also very important difference. Now the next step is to run all the tests and see if the new one fails. This validates that the test harness is working correctly and that the new test does not mistakenly pass without requiring any new code. This step also tests the test itself in the negative, so to speak. It rules out the possibility that a new test always passes and is therefore worthless. The new test should also fail for the expected reason as well. This increases confidence, although it doesn't guarantee that you're testing the right thing, and only passes if the test results indicate what is expected as well. And in step 3 we have write some code. The next step is to write code that causes the test to pass. The new code written at this stage isn't going to be perfect and may, for example, pass the test in an elegant way, or in most cases probably a very inelegant way. This is acceptable because later steps improve it and hone in on a particular result that you're expecting. At this point, the only purpose of the written code is to pass the test. No further and therefore untested functionality should be predicted or allowed for any stage. Now it's step number 4, we have run the tests. So if all test cases are now passed, the programmer can be confident that the code meets the test requirements. Remember, I said this is testing more against requirement than it is against function. This is a good point from which to begin the final step in the cycle, which is refactoring the code. Now the code should be cleaned up as necessary. Move code from where it was convenient for passing the test to where it logically belongs. Remove any duplication you can find. Make sure that variable and method names are represented in their current use. You need to clarify any constructions that might be misinterpreted. If you use Ken Beck's 4 rules of simple design to guide you, as well as anything you know about writing clean code, by rerunning these test cases, the developer can be confident that the code refactoring hasn't damaged any existing functionality. The concept of removing duplication is it's a very important aspect of software design. In this case, however, it also applies to removing any duplication between the test code and the production code. For example, magic numbers or strings repeated in both to make the test pass in step 3. Now we do have another step here which isn't outlined, which is step 6, repeat. Starting with another test, the cycle is then repeated to push forward the functionality. The size of the steps should always be small, with as few as 1 to 10 edits between each test run. If new code doesn't rapidly satisfy new tests, or other tests fail unexpectedly, then the programmer should undo or revert back in preference to excessive debugging, which can be very timely. Continuous integration helps by providing revertible checkpoints. When using existing libraries, it's important not to make increments that are so small as to be effectively merely testing the library itself, unless there's some reason to do so in the first place. So on the subject of best practices, test structure is very important. Effective layout of a test case ensures that all required actions are complete. It improves the readability of the test case, and it also smooths up the flow of execution as well. Consistent structure helps in building a self-documenting test case. A commonly applied structure for test cases has a setup, an execution, a validation, and a cleanup. So if you go through each one of them, a setup would be put the unit under test, or UUT testing, or the overall test system in the state that it needs to run the test. Execution, you need to trigger the UUT and perform the target behavior and capture all of the output, such as returning values and output parameters. This step's usually pretty simple. Next we have validation. Validation ensures the results of the test are correct, that these results may include explicit outputs captured during execution or state changes in the UUT. Now cleanup, which a lot of people don't do. Cleanup restores the UUT or the overall test system to the pre-test state. This restoration permits another test to execute immediately after this one is complete. One of the last things that you want to happen is to come to rerunning another test to find out that the environment is still in the state it was from the previous test, and you have to go and reset XYZ parameters before you can continue. That should all happen in the cleanup phase. So why should you use test-driven development? Well, a big advantage of TDD is that it enables you to take small steps when writing software. For example, assume you add some new functional code, compile it, and you test it. chances are pretty good that your test will be broken by the defects that exist in the new code. It's much easier to find and then fix those defects if you've written 2 new lines of code rather than 2,000 lines of code. The implication is that the faster your compiler runs and you get new code, and the faster the regression test suite is, the more attractive it is to proceed in smaller and smaller steps, only adding very, very small units of code at any particular time. It's generally good, and I usually prefer to add a few lines of functional code, typically less than, 10, 20, before I recompile and run tests again. The test can be quickly adapted to serve new requirements or as new bugs are discovered as well. So here we'll deal with some myths commonly associated with TDD. So the first one, you create a 100% regression pack. Although that does sound like a good goal, and it is, it's not going to be realistic for quite a few reasons. You may have some reusable components or frameworks to use, which I've downloaded or purchased, which don't come with the test suite, nor perhaps even with the source code itself. Although you can and often do create black box tests which validate the interface of the components, these tests won't completely validate the component. The user interface is really hard to test, for instance. Although the user interface testing tools do in fact exist, not everyone owns them, and sometimes they're difficult to use. A common testing strategy is to not automate user interface testing, but instead hope that the user testing efforts cover this important aspect of your system. I'm sure they probably would anyway, as you do other tests on the system anyway. It's not an ideal approach, but it's still a very common one. Some developers may not have the team skills adequate, or the testing skills. Database regression testing is a fairly new concept and wouldn't be supported by any of these tools. You may be working on a legacy system and may not yet have gotten around to writing tests for some of the legacy functionality. It's just a few. So the unit test forms 100% of your design specification. People that are new to agile software development, or people claiming to be agile but who really aren't, or perhaps people who have never been involved with actual agile project, will sometimes say this. The reality is that the unit test from a fair bit of design specification. Similarly, acceptance tests form a fair bit of your requirement specification. But there's more to it than this. Because if you think about the production code before you write it, you're effectively performing detailed design, as I highly suggest reading more information on this, because understanding how unit tests can't factor into all of the design specification is very important. So you only need to unit test. Well, quite simply, that's completely false. TDD is sufficient for testing. TDD at the unit or developer test, as well as the customer test level, is only part of the overall testing effort. At best, it comprises your conformity and your testing efforts. And the very last one we have, TDD doesn't scale. It's partially true, although it is pretty easy to overcome. TDD scalability issues include your test suite takes too long to run, which is a common problem with equally common solutions. First, you need to separate your tests into 2 or more components. One test suite contains the tests for your new functionality that you're currently working on. The other test contains all the other tests. You run the first test suite regularly, migrating all the tests for mature portions of your production code to the overall test suites as appropriate. The overall test suite is run in the background, often on a separate machine at night, generally with some kind of automation software. At scale, I've seen several different levels of test suite. Development sandbox tests, which run 5 minutes or less. Project integration tests, which run in a few hours or less. and a test suite that may run in many hours or even several days that is run a lot less often, maybe even just once a week. On one project, I've seen a test suite that runs for several months, which was focused on load and stress testing of hardware, which is very indicative of something that you would throw at a hardware problem anyway. Not all developers know how to test either. You'd be very surprised how many know how to test effectively. It's often true, so if you get them some appropriate training and get them prepared with people with unit test skills, they'll be fantastic. Anybody who complains about this issue more than often or not seems to be looking for an excuse not to adopt TDD rather than just having to deal with it. Everyone might not be taken by the TDD approach. Taking a TDD approach to development is something that everyone on the team needs to agree to. If some people aren't doing so, then in order of preference, they either need to start, they need to be motivated to leave the team, or your team should give up on TDD.